All right, let's dive into the latest chapter of a pretty legendary series, the McFun Chicken Box. Now, if you're not familiar, this whole series is about one thing, the quest to build the most ridiculously powerful PC in the smallest possible space. We're talking cramming the absolute best of the best into a tiny little box.
And that quote right there, that's the entire philosophy. This isn't about building something practical or sensible. No, this is about pushing engineering to its absolute breaking point, just to see what's possible. Creating a machine with just an insane amount of power for its size.
And that really is the million-dollar question for version 5.0, isn't it? The heart of this challenge is the brand new 5090 reference graphics card. This thing is a 600-watt monster, a literal heat-generating nuclear bomb. And the idea of stuffing that into a tiny ITX case, well, it sounds completely impossible. So here's how this story unfolds. We're going to start with the grand vision, then watch as it all goes horribly wrong. From there, we'll dive into some serious hardware hacking, tune the whole thing for silence, and finally, see if we actually unleashed a performance monster. It's a heck of an engineering journey, so let's get into it. You know, this entire build, this whole crazy idea, it all started with just one single component, NVIDIA's 5090 reference card. See, unlike all the giant partner cards, this thing is an absolute marvel of engineering, and this entire system was designed from the ground up to take advantage of its very unique design. And the difference in design here is just fascinating. The Reference 5090 is this sleek two-slot card that's built to let air flow straight through its cooler. The non-reference cards, they're just huge. They brute force the cooling, and the air has to take this weird, inefficient L-shaped path. Now, yeah, the reference card runs a bit hotter by default, but that straight-through airflow, that design is the secret sauce for making a custom cooling setup work in a super small case. So with the GPU picked out, the next step was to build the perfect PC around it. And on paper, I mean, every single component was top of the line, a perfect match. In reality, it was a total, complete disaster just waiting to happen. And here is that all-star lineup. We've got the Fractal Design Ridge case, which was chosen specifically for its separate compartments and side vents. Theoretically, a perfect home for that 5090. You pair that with the best gaming CPU on the market, a beast of a power supply, tons of fast memory. I mean, this build should have been absolutely flawless. And then we turned it on for the first test, and the results, oh, they were bad, like shockingly bad. Instead of a high-performance machine, we had a thermal nightmare on our hands. The GPU temperature just skyrocketed to 90 degrees Celsius, way into the red zone where it starts throttling itself and killing its own performance. The perfect plan? It had failed, spectacularly. So what on earth went wrong? This is where the real project begins. This is where we stop just assembling parts and start actually engineering. We had to tear the whole thing down to figure out and fix the critical, fatal flaws in the design. Okay, so after a ton of digging, the first culprit was found, and honestly, it was a huge surprise. It was the case itself. Those stylish side panels on the Fractal Ridge, turns out, even though they're covered in little holes, the actual open area is tiny. They were acting like solid walls, trapping all the hot air and creating this nasty vortex of heat right next to all the components. The solution had to be drastic. We took those beautiful side panels to a CNC machine and just carved massive holes right into them. Then, after trying out all sorts of materials, we found this perfect high airflow wire mesh, painted it white to match, and ended up with custom panels that look like they came from the factory but breathe a million times better. Now, with the new panels, things got better, but still not good enough. The next big discovery was that the problem wasn't getting cold air to the GPU. The real issue, the real bottleneck, was getting the scorching hot air away from it. So the solution was this wild, custom push-pull system, and this took some serious surgery. We literally took a saw to parts of the case frame, used a shorter PCI riser to physically move the graphics card, and then we crammed fans on both sides. So now, two slim fans push cool air in, and two super powerful Noctua fans on the other side aggressively yank the hot air out. That's a total of 6 fans dedicated just to the GPU. Okay, so the GPU was finally tamed. But then, smoke tests revealed a whole new problem. That down-pressure CPU cooler, it was just blowing hot air down onto the motherboard, where it had nowhere to go. It just got trapped and sucked right back into the cooler's intake. It was creating its own little hot air cyclone. The fix for this one was just pure genius. We tested a bunch of different fan types, and the winner was this little high-speed turbofan. We designed a custom duct that sits right on top of the CPU cooler, sucks up all that waste heat, and just shoots it at high speed directly out the side of the case. No more recirculation. Problem solved.
So the hardware has been hacked, the cooling is finally working. But look, a powerful PC that sounds like a jet engine taking off is basically useless. So now we get to the final, and maybe the most crucial step, the art of tuning everything to be whisper quiet.
And believe me, this was not easy. This took creating custom fan curves for all 8 fans inside this tiny case. The goal was twofold. At idle, we wanted complete silence. The GPU fans don't even spin. But under a full gaming load, we wanted a controlled low hum, right around 45 decibels. Every single group of fans has its own speed, its own target, its own profile. Okay, so after a full month of designing, cutting, testing, and tuning, was it all worth it? It was time to find out. And the final performance numbers, they weren't just good. They were absolutely, stunningly good. So that final GPU temperature under a full gaming load, a ridiculously low 71 degrees Celsius. Now, to put that into perspective, that is a full 9 degrees cooler than the very same card running on an open-air test bench with literally infinite airflow. All that hacking didn't just tame the heat. It turned a cramped little box into a high-performance wind tunnel that's actually better than open air. And with all that cooling headroom, we could finally push the hardware. After a bit of overclocking, the final TimeSpy Extreme score broke 27,000 points. Now that isn't just a small bump. That is a massive leap over the card's stock performance. This tiny little ITX box is now competing with giant, custom water-cooled desktop towers. But what about actual games? Well, the results were just as crazy. Playing F125 at 4K resolution with every setting cranked to the max and frame generation on, this little machine was pushing over 300 frames per second. That is a level of performance that most full-size PCs can only dream of, and it's all coming from a box you could literally fit in a backpack. So was all this trouble really worth it? I mean, couldn't we have just bought a bigger case and been done in an afternoon? And that question gets us to the final and maybe the most important point of this whole project, the philosophy behind it all. And that's really what this is all about. The goal was never just to have a fast computer. It's the thrill of facing what seems like an impossible engineering challenge, breaking it down piece by piece, and creating a clever, elegant solution. The struggle, the late nights, the problem solving, that is the real reward. Because in the end, the joy isn't just in using something extraordinary. It's in knowing you were the one who built it.